And we have on page 113, okay, and okay, just kind of doing a bit of a recap of stuff to be looking into in preparation for the first test. We have in number 32, just going back to what we have in the case of the FOIL method. Okay, so we have multiplying a couple of binomial expressions, and this time we have the letters W and Y involved. So if I were to take what we have in this particular problem case, you have first product, you have 5W to the third times 2W to the third, so we have 5 times 2 is 10. And we have W cubed times itself, okay, that is going to be W to the sixth. And for the outside product, okay, so you have 5W to the third times negative Y squared. So you have a positive times a negative is a negative. And here we're going to have subtracting 5W to the third Y squared. And for the inside product, okay, so we have 6Y squared multiplied by 2W cubed. And for the coefficients, okay, I have 6 times 2, which will be 12. And with the variable factors, if I put these in alphabetical order, we're going to have W to the third times Y squared. And as for what we have in the case of the last product, okay, we have a positive times a negative is a negative, and we got 6Y squared times Y squared. So we have Y squared times Y squared becomes Y to the fourth. And looking at what we have now, okay, the first term we have 10 times W to the sixth, and that is its own term in W to the sixth. For the middle two terms, okay, we can combine these together. We have negative 5 plus 12 W to the third, Y to the second. So this will come out to positive 7 W to the third, Y to the second. And once again, we have the last term at minus 6 times Y to the fourth. And so these three terms will make the output, okay, for what we have in multiplying these particular expressions. And for what we have in the case of number 34, and here we have a couple of expressions, this time in the same variable, and that being the letter T. And so we have 9 times T minus 4, and you have multiplied by the quantity of 9T plus 4. And again, you have almost the same terms, except you have subtraction in one set, addition in the other. And so we're going to have what would be a difference of squares in the output. So first of all, we have 9T times 9T, so this would be 81 T to the second. And for the outside product, okay, so you have a positive 36T. Inside product, this would be a negative 36T. And for the last product, we come out to negative 4 times 4, which would be negative 16. And we're going to have in the result here, okay, we're going to have the outside and inside products to cancel out. And so we have in the output, we come down to 81 T squared minus 16. All right, and again, just for those exercises, now I did utilize the conventional FOIL method approach, but if you went with like the 2x2 matrix approach, or what they call the box method, that would also be a viable option. Okay, now in looking at shifting gears a bit, so going from multiplying expressions to factoring polynomials, and we have in the case 46. Okay, now we're looking at factoring and going back to the variable t. So we have 12t squared. We have minus t minus 6. Okay, and here, okay, this is a factorable trinomial. Okay, and we have 12t squared negative t minus 6. Now, you look to see if there is a greatest common factor, and the highest term that will go into 12t squared negative t and negative 6, that is only going to be 1. And in terms of factoring into binomial expressions, again, we can take, say, as a course, the factoring by grouping. And again, we have in the process, you're looking at the first and the last coefficients in the trinomial. So we have a positive 12 and a negative 6. And multiplying together, so you have 12 times negative 6. Okay, so we have negative 72. And again, looking for factors of negative 72 that will add or subtract to minus 1, which is a coefficient for negative t. Alright, so we're going to need the factors to be such that there will be more weight given to the negative factor than to the positive. Okay, so for factors of negative 72, and we're looking at the sum to be negative 1. So again, when we had formed negative 72, okay, again we had a positive 6, or I should say positive 12 and a negative 6. And 12 plus negative 6 is on the plus side at 6, but we need the sum to be on the minus side at negative 1. So in this case, two numbers are going to negative 72. We have negative 9 and 8 among many other combinations, but negative 9 and 8 will be the only combination where the sum of the terms will come out to negative 1. Okay, so we're going to have, with these coefficients, we're going to split up the negative t into two terms consisting of negative 9 and 8 as the coefficient. So we have with 12t squared minus t minus 6 okay, so we're going to have in this case, all right, so we got branching out, we have 12t squared minus 9 times t, then we have followed by plus 8 times t minus 6. Okay, and so we have setting the stage for grouping. Okay, so if I pair up the first two and the last two terms in parentheses, so we have 12t squared minus 9 times t. And again, we have the middle operation will be addition. So here we're going to have addition of the quantity of 8t minus 6. And looking at drawing out, okay, the greatest common factors from each pairing. Okay, so 12t squared minus 9t, the greatest common factor here is going to be 3t. And 3t into 12t squared minus 9t. Okay, we're going to have the quantity of 4t minus 3. And we have plus, okay, and then for 8t minus 6, now the greatest common factor, okay, that is going to be at 2. And 2 will go into the binomial 8t minus 6, which would be 4t minus 3. And so we have, with the groupings, okay, notice we have a common binomial factor with 4t minus 3. That'll be one factor. And again, the other factor will consist of joining together the outside terms and operation. So we're going to have the formation of 3t plus 2. Okay. And you can always go back and check. Okay, again, 4t times 3t is 12t squared. Outside product is going to be a positive 8t. Inside product is going to be negative 9t. So 8t minus 9t is a negative t. And negative 3 times 2 is a negative 6. So we have, with the factors, again, we have on the side of subtraction, we have 4t minus 3. And on the side of addition, we have the quantity of 3t plus 2. All right, and now we have from the set, Okay, now number 46, okay, we have working with a single variable. Now for 47, okay, we're looking at two variables to work with, and here we have with 8x cubed minus 40x squared y. And we have plus 50xy squared. Okay, and if you notice, okay, first of all, before we try to factor into binomial expressions, okay, now we want to see if there's a greatest common factor other than just 1. And so if you notice, we have even coefficients throughout. Okay, so you have 8, negative 40, and 50. And the highest number that will go into 8, negative 40, and 50, that is going to be at 2. And notice we have, all of these terms have an x in common. So we have at this stage for our trinomial. Okay, so we have, again, just factoring out 2x. So 2x will go into 8x cubed 4x squared times, and it will go into negative 40x squared y, so you have negative 20. And so we have a degree in x left over times y. And 2x into 50xy squared, so we have a positive 25 y squared. So we're going to be forming factors from this trinomial. Okay, and so 2x is going to be waiting, sort of on standby. So just kind of moving to the side here. So looking at factoring this trinomial. Okay, so once again, looking at factoring by grouping. Okay, so we have 4 times 25. And 4 times 25, okay, so this will be 100. And we're now looking for factors of 100 that will add up to the middle coefficient, minus 20. Once again, in terms of how we got to 100, again, we have worked with 4 and 25. However, 4 and 25 add up to 29. Okay, so we're in the wrong direction with both terms positive. So we need both terms to be negative. And the combination that will add up to negative 20 will be the same value. So you have negative 10 and negative 10. Negative 10 times negative 10 is going to be 100. And negative 10 plus negative 10, so this will be minus 20. And so just looking at taking what we have, with 4x squared minus 20xy plus 25y squared. Again, so we're going to split up the negative 20xy so we have 4x squared, and then we have negative 10xy, and we have another negative 10xy, and we have plus 25y squared. And looking at pairing up, okay, the first two terms, again, we have 4x squared minus 10xy. Okay, first half in the pairing, easier process, whereas with the second half, because we have subtraction in the middle, You got to be careful with the signage. Okay, so we have negative 10xy. Okay, so that'll be the opposite sign of 10xy. And for 25y squared, again, I'm factoring out subtraction, indicate in this case essentially negative 1. Negative 1 will go into 25y squared minus 25y squared times. Again, you can always check removing parentheses, and this first set, and then last two terms, negative 10xy and plus 25y squared. And so looking at drawing out the greatest common factors, so into 4x squared and negative 10xy, okay, we have the GCF, okay, that is going to be at 2x. And we have into the first binomial, we have 2x minus 5y times. And bring down the subtraction. Now the highest order term or greatest common factor, they'll go into the last pair. Okay, we have 5 and y. And 5y into 10xy minus 25y squared. This will also go 2x minus 5y times. And so, looking at what we have here, we have a common factor with 2x minus 5y. And the outside terms, they will also form 2x minus 5y. So here we have repeating factors. And so we have in the end result, we have the quantity of 2x minus 5y raised to the second. Okay, and so just looking at what we have in the overall picture. Okay, so when I started out, I factored out 2x, and then I had moved over to the side factoring this trinomial, okay, which came out to 2x minus 5y squared. And so just relaying what we have here. Yeah, so we have in carrying over, there we go. All right, so we have, for the end result, we're going to have 2x, and this is going to be times the quantity of 2x minus 5y raised to the second. Okay, so that'd be the complete factorization of what we have in the case of 47. Quite a bit of work to do on the side here. It's about like, in a way, something that seems almost akin to doing your own tax. It's like doing a lot of work on the side, and then just taking those numbers from those separate pages and then putting into your 1040 form. Okay, so 47, again, you have another case of factoring, and again, we have through the pathway of factoring by grouping. All right, now for what we have in the case of number 54, okay, and here, okay, we have m to the 6th plus 9m to the 3rd, and we have plus 8. Okay, now we have a trinomial. Now this one can be factored. Okay, now this expression happens to be quadratic in m to the 3rd. Okay, because you have like a 2-to-1 ratio. And okay, so for m to the 6th, I can factor out as m to the 3rd times itself. And then we have with 8 factors of 8 that will add up to 9. So you have m to the 3rd plus 8. And we're going to have times the quantity of m to the 3rd plus 1. Okay. Now, here, if you notice, we have in the factors. Now we have a sum of cubes. I don't think there's going to be, in the test, an exercise involving factoring the sum of cubes or the difference of cubes. And for all intents and purposes, this version of the answer, okay, might be what the problem was asking for, but just in case, right? If you're looking at factoring further, you have like, again, for the sum of cubes, you have a to the third plus b to the third. Okay, you're going to have factoring out, okay, the sum of the cubic roots of a and b. And we have with the trinomial factor, have a squared minus ab plus b squared. And if I were to take, let's say for m to the third plus 8, you have m to the third plus 8. Now, m to the third is already the cube of m. 8 is going to be the cube of 2. So you think of a is represented by m, b represented by 2. So this is going to go to m plus 2. And we have times the quantity. Now we have a squared becomes m squared. And we have minus a times b, which will be the subtraction of m times 2. And we'll just write this as negative 2m. And plus b squared is going to be plus 2 squared, which is going to go to 4. As for what we have for m to the third plus 1, for m to the third plus 1, okay, so you have m to the third is the cube of m, and 1, of course, will be the cube of 1. Your a plus b, again, translates out to m plus 1, and then a squared is m to the second, minus ab will be the subtraction of m times 1, so we have negative m. And we have plus b squared, so you have plus 1 squared, which is going to be at 1. And so just relaying this back, okay, so again we have with m to the third plus 8, we have m plus 2 times m squared minus 2m plus 4. And then for m cubed plus 1, so we have m plus 1. And we have times the quantity of m squared minus m plus 1. Alright, so this one was a little bit drawn out, okay, because we had, again, in the factors, you had 2 sets of the sum of cubes. Okay, now, in the case of when we looked at polynomial expressions, now we had crossed over immediately afterwards into working with rational expressions, and for this particular group, okay, that we have from page 113, okay, we have for the lead-in. Now we have for number 61, again, we're looking at combining rational expressions, not working with equations, but combining rational expressions. And for what we have in the case of 61, okay, and we're looking at, in this case, we're working with the rational expression, and it says to simplify and find out just what the restricted values are going to be. So here we have m to the second minus 16 all over m squared minus m minus 12. And for what we have in the setup, okay, so for m squared minus 16 over m squared minus m minus 12, again, if I factor, we have in the numerator, we have m plus 4 times the quantity of m minus 4. For m squared minus m minus 12, if I factor, we'll have m minus 4 times the quantity of m plus 3. And I'll just take this just one step further. Notice we have a common factor between the numerator and denominator expressions. Okay, so we have a set of m minus 4 terms to go out. So for the simplified result here, we have m plus 4 all over m plus 3. So that is the simplified ratio. But now we have for restricted values. Okay, again, we do have a stipulation, okay, that m squared minus m minus 12, because this expression is in the denominator. Okay, again, denominators cannot be 0. And we had factored out m minus 4 and m plus 3. So if the whole denominator cannot be 0, then neither can the factors. And just pinpointing just what m cannot be. So we have on the one hand, if m minus 4 cannot be 0, we have that m cannot be 4. And if m plus 3 cannot be 0, we have that m cannot be equal to negative 3. Okay, so those exclusions, they'll make up what are referred to as the restricted values. And it doesn't matter what order you place them, okay, but you have 4 and negative 3. And again, for what we have looking at rational expressions, and we have for number 65, okay, now we have 7 over 20x. Then we have plus 2 over 15x to the 4th. Now we're not working with an equation, but we're looking at adding together. And to be able to add fractions, we need the same denominator. And just looking at formulating, okay, what the least common denominator will be. So if we take with, say with the numbers 20 and 15. Okay, so you have with 20, we could go with like 4 times 5 or 2 times 10. And 2 is a prime number because the only natural number factors of 2 will be 1 and the number 2 itself. Now for the number 10, you got 1 times 10, but you also have 2 times 5. Okay, so you have 2 is a prime number again, and 5 is also a prime number. Now for the number 15, okay, we have 1 times 15, and 15 has prime factors with 3 and 5. And again, we have with the variable factor, okay, we have only the letter x. Okay, and in the case of what we have for the least common denominator, okay, you're looking at the highest degree or the most common representation from each of the factors that we have in 20 and 15, along with the highest degree representation of x between the denominators. Okay, so we have in the layout, and so just creating a pathway to the least common denominator. And again, you have with your prime factors. Okay, so I have 2, 3, and 5. So for the least common denominator, okay, so 2 doesn't appear at all from 15, but from 20 it does appear twice. And then 3 doesn't appear at all from 20, but it does appear once from 15. And from 5 it appears once from each of these. And then we have just for the variable, least common denominator, okay, you have the variable factor in x, and so you have the higher or highest degree representation of x, which is going to be x to the 4th. So the least common denominator, you have 4 times 3 is 12, 12 times 5 is 60. So least common denominator is going to be 60 times x to the 4th. And so looking at what we have in the setup, so I'm going to raise both of these ratios in terms of the least common denominator. Okay, so we have 7 over 20x again, looking at the denominator and the first ratio relative to the least common denominator. So 20 will go into 60 3 times, x will go into x to the 4th, x cubed times. So this first ratio is going to be multiplied by 1 in the form of 3x cubed over itself. As for 2 over 15x to the 4th, alright, so we have with the second ratio, we already have the 4th degree of x. And so we have 15 will go into 64 times. So this second ratio will be multiplied by 1 in the form of 4 over itself. And we have for the final case here, we got both denominators will now be 60x to the 4th. Now I can go ahead and combine the numerators. So we have 7 times 3x cubed, so this will be 21x cubed. And we have plus 8, and we have all over 60 times x to the 4th. And this will be the final result in number 65. All right. Now, for what we have in the case of 67, okay, this time we have not 2 but 3 ratios to combine. And here, okay, so we have 4 over x squared. Okay, we have plus 3 over x plus 3. You have minus 2 over x. Okay, so for the least common denominator, we can just go ahead and draw this out. Okay, so we have for the least common denominator. Okay, if you notice all the denominators, okay, we have this variable expression. So we have x squared, x plus 3, and x. Now for the single terms, x squared and x, again, you had the higher or highest degree representation is going to be x squared. And again, we have the binomial, x plus 3. So we have the least common denominator. It's going to be x squared times the quantity of x plus 3. So if I take what I have in the first ratio, so I have 4 over x squared, and x squared into the least common denominator, we still have x plus 3. And we have plus, okay, now we have 3 over x plus 3. And x plus 3 into the least common denominator. Okay, we have x squared. minus. Okay, now we've got 2 over x, and this is probably the trickiest one in terms of raising, in terms of least common denominator, because here you got 1 degree in x, but as you take into the least common denominator, you still have 1 remaining degree in x that sticks, and then you still have x plus 3 to work with. And so for what we have in the developments, and what I'm going to do here is kind of take this on out. Okay, so I'm going to have 4 times the quantity of x plus 3. I have plus 3x squared, and then I have minus 2 times x times the quantity of x plus 3. Again, this is going to be all over x squared times the quantity of x plus 3. And so looking at the distributing among the terms in the numerator, so you have 4 all over the quantity of x plus 3. So this will be 4x plus 12. We have plus 3x squared. And have negative 2x times x, so we have negative 2x squared. And negative 2x over 3, so we have minus 6x. And we have all over x squared times the quantity of x plus 3. And just combining the like terms in the numerator. Okay. And so we've got 3x squared minus 2x squared. So you have x squared left over. Now in the first degree in x, we have 4x minus 6x. So this will be a negative 2x. And then we have the only constant in the numerator, which is going to be plus 12. Again, we'll have all over x squared times the quantity of x plus 3. And that'll be the end result, okay, for what we have in 67. Okay. Now, in taking what we have, crossing over to the threshold of working with equations. And we have for 76. Okay, so here we have m plus 2 over 3. You have minus, okay, we have the ratio m minus 4 over 4. You have equal to m plus 1 over 6. Then we have minus 1. Okay, and just now for the least common denominator, I'll just kind of draw this out. Okay, so 3 is a prime number. 4 goes to 2 times 2. 6 goes to 2 times 3. So your prime factors you have with 2 and 3. And for the least common denominator. Okay, so you have your prime factors. Okay, so 2 appears once, it appears twice, and then it appears not at all. Okay, so you have the greatest number of appearance is going to stem from 4. And as for 3, it appears once, either from 3 or 6. So the smallest number that 3, 4, and 6 will go into will be 12. Now, I'm not going to write all of these fractions in terms of least common denominator 12. And the reason for this is that I'm now working with an equation. So if you have an equation, you can use the least common denominator, okay, to cancel out what we have in the original denominators. So if I multiply everything out by the least common denominator, okay, so we're going to have 12 times the quantity. So you have m plus 2 all over 3. And bringing down the subtraction, so you have 12 times, okay, the quantity of m minus 4 all over 4. Okay, we have is equal to 12 times the quantity of m plus 1 over 6. And you have minus, okay, 12 times 1. Okay, so we have in the setup, okay, and we can look at this through the perspective of cross multiplying. Okay, so you have like 3 will go into 12 4 times. Now we're going to bring down the subtraction here, but now we've got 4 will go into 12 3 times. 6 will go into 12 2 times. And just being careful with the signs here. Okay, so again, we got 3 will go into 12 4 times, and 4 will be distributed all over m plus 2. Again, we had the subtraction. Again, 4 went into 12 3 times. But again, we're going to distribute negative 3 over the quantity of m minus 4. And again, we have 6 went into 12 2 times. And that is going to be distributed over the quantity of m plus 1. And we got negative 12 times 1, which will be minus 12. And we have in the follow through, so we have 3 distributions or 3 sets of parentheses to take care of. So we have with the first distribution 4 over the quantity of m plus 2. This will be 4m plus 8. Then we have next in line, we have negative 3 over the quantity of m minus 4. So this will be minus 3m. Negative 3 over negative 4 becomes positive 12. And 2 over the quantity of m plus 1. So we have 2m plus 2. We have minus 12. And we have combining the m terms and the constants together on each side. So you have 4m minus 3m becomes m. 8 plus 12. Okay, that will be 20. And we have is equal to 2m and 2 minus 12. Okay, so that will be negative 10. So you have like terms on opposite sides here. And what I'm going to do here, I normally like to keep the variable on the left-hand side of the equation. But in this setup, okay, I got the smaller m term on the left, so I'm going to take care of the smaller m term by subtracting. And that is to avoid having to work with negative numbers any more than is necessary. So here we have 20 is equal to 2m minus m becomes m minus 10. And if 20 is equal to m minus 10, well, it's going to follow that 30 is equal to m, or equivalently, okay, we have for the missing value m, okay, we have again at 30. All right. Now, another case here, and okay, so when we cleared out the denominators, okay, we had a linear equation where we had like terms on opposite sides. Now the next item that we have leading into a quadratic equation that we have yet, okay, to establish in standard form. And in the case of 80, okay, so you have 3y squared minus 4y is equal to 8 minus 6y. Okay, so you have only the variable y, okay, and you have a quadratic equation, but we don't have this one in standard form. That is, we don't have the equation set equal to 0. So what I can do here is that I can just move the 6y and the 8 terms from the right. So you have adding 6y, also taking away 8, so we have negative 4y plus 6y. Okay, so this is going to be a positive 2y. And we have minus 8. And we have this equal to 0. Okay, and this one now. I could do this stuff like the factoring by grouping, but since the coefficients are just low enough. Now 3 is already a prime number, so if this is factorable, 3y squared goes to 3y and y. And I need the combination of the factors of negative 8, where the outside and inside products will be on the plus side at 2y. And so for what is going to happen here, and it's going to turn out that for, then we have a plus 2 and a minus 4. So you got 3y squared plus 6y minus 4y is 2y, and we have minus 8. Now I'll just mention this. I can run through this right quickly. Yeah, so you have like your combinations of negative 8. You could have had plus 8 minus 1, or stuff like 3y minus 8y plus 1, or even 3y plus 4, y minus 2, 3y minus 4, and y plus 2. And if you notice, okay, there are other combinations too, but you could have, let's say just for instance, you can have like 3y plus 1, y minus 8. And if I had FOILed out what we have here, so you have like 3y squared, all these would have a first product of 3y squared. And also, they would have a last product of negative 8. But you need the right outside-inside product combination. So here we have negative 24y plus y, so you have negative 23y. Here we have minus 3y plus 8y. So you have plus 5y, and then we have plus 3y minus 8y, so you have a negative 5y. And here we have negative 6y plus 4y, so we have negative 2y. And with this combination, so you have 3y squared plus 2y minus 8. And that is the only combination where we're going to have 2y to come about. Any other combination trying to factor 3y squared and negative 8, you're not going to have the 2y to result from combining the outside and inside products. Okay, and again, factoring by grouping was an option, but again, with the digits being low enough, it might be a quicker route to just use a little bit of trial and error. Okay, so we have with utilizing at this stage the zero product property, setting each of 3y minus 4 and y plus 2 equal to 0. So if 3y minus 4 is equal to 0, we have 3y is equal to 4, and so we have y is equal to 4/3. As for y plus 2 is equal to 0, okay, so I take 2 away from both sides, and so I had that y is equal to negative 2. Okay, so we have with our solutions, okay, we have that y is equal to 4/3 as well as negative 2. All right, and now we'll get into 85 in just a moment. But I tell you what, just taking what we have here. Let's see. 54. Let me check something. Okay. Yeah, we'll look at 85. Okay. So here we have crossing over to radical equations. And, okay, so we have in the variable k, okay, right now we have the square root of k plus 7 and we have minus, okay, the square root of 3 minus k is equal to 2. Okay. All right, so here we have two terms in the same kind of radical. And again, what I can do here is that I can isolate either one of these two. And I tell you what, if I start out by adding the square root of 3 minus k to both sides, okay, so I have by itself, so I have the square root of k plus 7, and I have equal to 2 plus the square root of 3 minus k. All right, so we have, looking at what we have now, okay, so you have radical terms in the square roots apart from each other. Now I can free up k plus 7 from the radical by squaring both sides. So we have here for the square root of k plus 7 squared. Okay, again, the exponent will undo the square root. Okay, so k plus 7 is going to be freed up. Okay, now I'm still going to have radical remnants once I take the square of 2 plus the square root of 3 minus k. So again, this will translate out to 2 plus the square root of 3 minus k times itself. And we have taking the FOIL. Okay, so I have 2 times 2 is going to be 4. Outside we have 2 times the square root of 3 minus k. Inside we have 2 times, okay, the square root of 3 minus k. Okay, now, again, you had the square root of 3 minus k times itself. And if you have a repeating square root expression, this will be like the square root of 3 minus k to the second. And that is just going to become 3 minus k. So we have, and following through, so you got 4 from the first product. Outside and inside products, you got 2 square root of 3 minus k plus another 2 square root of 3 minus k. So this will be 4 times the square root of 3 minus k. And then for the last product, again, this is going to translate to 3 minus k. And here we have 4 plus 3 is 7. Plus 4 times, okay, the square root of 3 minus k. And we have negative k left over. So just transporting to what we have on the right hand side of the equation. So I'm just going to copy this. Okay, so we're going to have like terms on opposite sides. Okay, and I'm going to isolate the radical we have here. So I'm just going to move the 7. Next we're going to have cancellation of the constants. And I'm going to move this k by adding. All right. So for what I have in the development, okay, so you have k plus k becomes k squared. In this case, we have, I am going to square out, but I have k plus k is going to become 2k. And got 2k is equal to 4 times, okay, the square root of 3 minus k. Alright, and so now you have your option. You can isolate the square root of 3 minus k if you divide by 4, but you would have a fraction on the left hand side. So what you can do instead, if you want to avoid fractions, you can go ahead and square both sides. I just thought of another way, but we'll get to this in just a moment. Okay, so we have in the layout, so 2k quantity squared, this will be 4k squared. And we have 4 squared is going to be 16. Square root of 3 minus k squared will be 3 minus k. So you got 4k squared. 16 times 3 is 48. 16 over negative k, this will be a minus 16k. Alright, so we have a quadratic equation. Okay. And if we put this in standard form, okay, so I'm going to move the 16k and the 48 over. So you have 4k squared plus 16k minus 48. Okay, we have is equal to 0. And what I can do here in terms of the follow through, okay, is that, so you got greatest common factor in the set is going to be at 4. Okay, so if I divide the equation by 4, so I'm going to have k squared plus 4k minus 12, okay, is equal to 0. And looking at factoring, so we have the quantity, so I have k plus 6 times out of k minus 2 is equal to 0. Now we're going to have apparent solutions for k. If I set k plus 6 equal to 0, okay, we have possibly that k is going to be negative 6. And from k minus 2 equal to 0, okay, k might possibly be equal to 2. Okay. And so just looking at what we have and checking what we have in the solutions. Okay, so again, you don't have to write out the checking, but I just want to mention. So we have in the original equation, so we have with square root of k plus 7, if k is negative 6 plus 7 is going to be a 1. And we have 3 minus negative 6 is going to be 3 plus 6, which is going to be 9. So right now we have square root of 1 minus the square root of 9. And I'm trying to set this equal to 2. Square root of 1 is 1. Bring down the subtraction. Square root of 9 is going to be 3. And guess what? 1 minus 3 is negative 2. So if I have k is equal to negative 6, it's going to end up trying to say that negative 2 is equal to 2, which is false. And so we have, in effect, okay, so negative 6 becomes extraneous. That is, it strikes out. And if I check k is equal to 2, so you got the square root of 2 plus 7 is going to be the square root of 9. And then we have minus, then we have the square root of 3 minus 2. So we have 3 minus 2 is 1. And after substituting, so the square root of 9 is 3. Bring down the subtraction, square root of 1 is 1. 3 minus 1 is 2. And we have that 2 is equal to 2. And that is true. So when I tried negative 6, the left-hand side became negative 2 as opposed to 2. But with k equal to 2, I was able to have consistency on both sides. So k equals 2 checks out. And so for what we have here, okay, we have 2 to be the only solution for what we have in the case of number 85. And let me just check something right fast. Okay, I just want to make sure that, I think there might have been a typo somewhere, but just wanted to. Okay, so we got here. Yeah, let's see. Yeah, that one. Yeah, that number 86. There was a typo in this one. I know what the author's trying to get to on this one, and yeah, there was a mathematical error in the textbook. So I'm just gonna bypass this one. Okay, now we have in the case of number 90. Okay, so we have, just going back to radicals, and this time where we have the presentation along the lines where we have non-integer exponents. And for number 90, okay, so you have 10 times w to the 2/3, okay, is equal to 1/10. And again, just a little reminder. Okay, so you have again, you have going hand in hand. You have the nth root of a to the m and a to the m over n. Okay, going hand in hand. Okay, so right now we have 10 times w to the 2/3. Okay, is equal to 1/10. And let's say that if I isolate the w to the 2/3, okay, so just give you a little bit of a visual. Okay, so if I divide by 10, so you have like 1/10 over 10, or you can say they have 1/10 times 1/10. Okay, so dividing the left-hand side by 10, so you have w to the 2/3. And dividing 1/10 by 10, or 1/10 of 1/10, this is going to be 1 over 100. Okay, now for w to the 2/3, if I rewrite this as a radical, now with w to the 2/3, Okay, so again, your n is at 3, m is at 2, a is at w, and just rewriting in radical terms. So your nth root is going to be the cubic root, and we have a w to the second. So for w to the 2/3, okay, so we have the cubic root of w squared and we have equal to 1 over 100. Okay, and in terms of working through what we have now, okay, I can undo the cubic root. So I can take both sides and raise to the 3rd power. Okay, now we already had a small fraction with 1 over 100, but once I cube out, it's going to get very small. So here, left-hand side becomes w squared, and then you have 1 over 100 times itself times itself. So you have 1 over 100 times itself, another 2 zeros times itself once more, so you have yet another 2 zeros. So you have w squared, okay, is equal to 1 over a million. And again, just going back to the square root property of equality. Okay, so I have x squared is equal to p. We have x equal to plus or minus the square root of p. And just on the same wavelength. Okay, so your p is this small fraction here. Okay, and so for the results in w, okay, so you have plus or minus. Okay, now you have 1 over. Now, and 1 million, okay, this is both a perfect square and a perfect cube. In terms of cubes, like 1 million is 100 times itself, and in terms of squares, well, 1,000 times itself gets you to 1,000,000. So for w, this would come out to plus or minus 1 over 1,000. And those would be the results for what we have in number 90. Now, in looking at now what we have for, and this is going to be sort of a lead-in, but just in case if there's a problem of this type that's going to somehow sneak in. And this is what we have with linear equations, and those items, okay, we have, which will be in chapter 1, but we have like the standard form of a linear equation. And we're looking at trying to express this in terms of a specified variable. Okay, so you're looking at expressing 4x minus 3y equals 6 in terms of the variable y. And what this means is that we get this equation in the form of y equals. So for 4x minus 3y is equal to 6, what I can do is isolate the y term. So that means I can move the x term at the other end. Okay, so we have by itself on the left, I have negative 3y. And it doesn't matter what order you place the terms. We'll say we have negative 4x plus 6. And we have, upon dividing both sides by negative 3, okay, so if I divide all the terms out by negative 3, say negative 3y over negative 3 becomes y. Negative 4 over negative 3, that negative over negative is going to be a positive, so you're still are going to be stuck with 4 over 3, and you have times x, so you have y is equal to 4/3 of x, and we have 6 over negative 3 becomes negative 2, So we have for y, okay, we have 4/3 of x minus 2, and had you kept this in fractional form, we could have said that we had y is equal to 4x minus 6 over 3 if you left this as a compact ratio. But I like to itemize in this particular case. All right. Now, another item where we have writing an equation in terms of a specified variable. So we have for number 96. It's like some of the topics technically cross over into subsequent chapters, but in terms of the exercises, even in ALEX, sometimes you get an early glimpse. Okay, and say if you're looking at trying to express this equation in terms of the variable b. Okay, so you have 1 over a is equal to 1 over b plus 1 over c. And for this equation, I want to get out of the fraction mode. So what I can do here is I can just multiply all the terms or all the ratios by the least common denominator. Okay, and in this one case you have a, b, and c. And so I can get out of the fraction mode if I multiply everything out by the least common denominator. So just multiply everything out by a, b, and c. So just for the first ratio, okay, so we have a's to cancel out. Then for the next, for 1 over b, okay, now b's are going to cancel out. And then we have abc times 1 over c, so c's are going to cancel out. So we have b times c is equal to a times c, and you have plus a times b. And we're looking at expressing this equation in terms of the letter b. And if you notice the terms with b, we have bc and ab. So what I can do here is that while bc is by itself on the left, I can move the AB term by subtracting. So here I have BC minus AB is equal to AC. So having this line up. So I'm still looking at trying to solve for the letter B. And guess what? These terms have the letter B. And let's say if I factor out B, B will go to BC, C times, and it will go into negative AB, negative A times. Again, we have C equal to AC. And so once I have B by itself, I have A times C all over C minus A. So B is equal to A times C all over C minus A. And a conversion like that, if you found that one to be difficult, I mean, don't feel bad. I remember years ago, as an undergraduate, I took a physics class, and there was like a part with I think it was like RLC circuits, and it was like writing like a set of fractions in terms of a special feature that was within the equation, and it had to be one of the denominators, and I had to go from the inverse of that to writing indirect terms So that one kind of an outlier in terms of conversions. Okay, now I'm just kind of going back, and we have looking into again both real as well as complex numbers, and we have in the case of number 104. And we have in this one we have 10t squared. Okay, we have plus 1210 is equal to 0. Okay, so we have 10t squared plus 1210 is equal to 0. And now we do have, I could either divide by 10 from the get-go or just divide by 10 later on. And I'll tell you what, we'll go ahead and, okay, so you have 10t squared plus 1210 is equal to 0. And in this, I can just, kind of like what I did from the previous exercises are the same kind. I can just get the variable term by itself. Okay, so you have 10t squared is equal to negative 1210. And if I take what I have here and write in terms of t squared, so I can just divide by 10 at this stage. So I have 10t squared over 10, so this will become t squared. Negative 1210 divided by 10, so we have a negative 121. And going back to the square root property of equality, so if I go from t squared to t is going to be plus or minus, okay, the square root of negative 121. Now just take this out a little further. If you've already got the answers, that's fine. So I just want to mention you have the square root of 121i. 121 is a perfect square value. And so we have with t, plus or minus 11i. In the case of itemizing, you have 11i as well as minus 11i. Now for what we have in the case of 105, okay, now we have, it's going back to looking at solving for x, and we have with this equation. Okay, so I have x times, okay, the quantity of x minus 4 is equal to negative 9. Again, okay, this looks almost like a factoring by grouping setup, but you don't do that unless that the constant that is isolated is 0. Okay, so since we have negative 9, we had to work around what we have. So we're going to undo the parentheses, and if I distribute, we have x times the quantity of x minus 4, so this will be x squared minus 4x is equal to negative 9. And just taking what I have and putting in standard form, that is setting the equation to 0. So we have x squared minus 4x plus 9 is equal to 0. Okay, so for what we have in the setup, okay, I cannot factor this trinomial into real integer coefficients. So the recourse here is, I guess among other possibilities, you have the quadratic formula. So you have a is at 1, and since we have the subtraction of 4x, we have b is negative 4, and with the plus 9, we have that c is equal to 9. And looking at solving for x, okay, so we have with the quadratic formula, so you got your negative b, we have the opposite sign of negative 4, Then we have plus or minus, okay, the square root. So you have b squared. This will be the square of negative 4. You have minus 4ac, so you have minus 4 times 1 times 9. Then we have all over 2a, which is going to be 2 times 1. Now, for what we have within the radical, again, the square of negative 4 is going to be positive 16. We've got negative 4 times 1 is negative 4 times 9 is negative 36. 16 minus 36 is going to be negative 20. And 20, they have another case of a number that is not a perfect square, but will be the multiple of a perfect square that is greater than 1. So you have the square root of negative 20, you have the square root of 20i. And the highest perfect square that will go into 20 is going to be 4. So I can branch out saying we have the square root of 4 times the square root of 5 times I. So we have in reduced terms, we have 2 times, okay, the square root of 5 times I. And so just taking what we have and putting back. Okay, so we have the x is equal to, so you have the opposite sign of negative 4 is a positive 4. And you have plus or minus 2 times the square root of 5 times I. And we have all over 2. And if you notice, you have even valued leading coefficients and reducing. So 2 will go into 4 2 times. And 2 will go into 2 times the square root of 5i, square root of 5 times I times. And so we have in compact notation, we have x is equal to 2 plus or minus the square root of 5i. And if we itemize, so we're going to have 2 plus the square root of 5 times I. And we also have 2 minus the square root of 5 times I. Okay. So again, we have just like number 104. Okay. Number 105 has exclusively complex roots. And now, in the case of what we have with 106, okay, so we're back in the terrain. Okay, so we have 6 times d to the 2/3 minus 7 times d to the 1/3 minus 3 is equal to 0. Okay, and now this equation, okay, this equation is going to be quadratic in d to the 1/3, since you have a 2-to-1 ratio between 2/3 in d and d to the 1/3. Okay, so for what we have right now, okay, so we just kind of run something in analogous fashion. Okay, so we have the equation is quadratic in d to the 1/3. Okay, let me just kind of step to the side here. So if I have 6x squared minus 7x minus 3. Okay, now I'm just kind of doing a quick run through. So if I looked at factoring by grouping, so you have your first and last coefficients. You have 6 times negative 3 will be negative 18. But I want the factors of negative 18 that will add up to negative 7. And guess what? Those numbers would be negative 9 and negative 2. Okay, so you have like negative 9 times negative 2. Make that negative 9 and positive 2. There we go. Negative 9 times positive 2. That's a negative 18. I was saying positive 18 for some reason. And negative 9 plus 2 is equal to negative 7. So I'm going to take what I have here and branch out. So again, we have what will be 6x squared minus 9x plus 2x minus 3 and if we look at factoring by grouping, so I have operation of addition in the middle. Here I have the quantity of 2x minus 3. So drawing out the, say the greatest common factors. Okay, so we have for 6x squared and negative 9x, greatest common factor, we're going to have 3x. We have times the quantity of 2x minus 3. And bring down the plus. And the greatest common factor of 2x minus 3 is only going to be 1. So we have for the factorization, so we have 2x minus 3, which we had to be shared, and the other we have at 3x plus 1. Okay, and one might ask, okay, what's this got to do with d to the 1/3? Okay, well, if you notice we had the same coefficients, even though we got a different letter and different degrees, we still had the same kind of application with the weights of the coefficients in the factoring. So we have like analogous to 2x minus 3. We're going to take 2 times. Now x is going to be corresponding to d to the 1/3, whereas d to the 2/3 and x squared, okay, run on the same parallel. So here we have 2d okay, so I have 2 times d, and let me so 2 times d to the 1/3 minus 3. Okay, times the quantity of 3 times d to the 1/3 plus 1. Okay, again we have this equal to 0. And you can always go back and check. 2 times 3 is 6, d to the 1/3, d to the 1/3 is d to the 2/3. And you got plus 2d to the 1/3 minus 9d to the 1/3, and you have minus 3. So from this setup, if I utilize the zero product property, okay, so if I set the factors to 0, okay, what I can do now is I can isolate the d terms. Okay, first of all, okay, so if I add 3 to both ends, so we have 2d to the 1/3 is equal to 3. And what I can do here is that I can isolate d to the 1/3, so we have with division by 2, we have that d to the 1/3 is equal to 3/2. And going from non-integer exponent to radical, so we have the cubic root of d is equal to 3/2, and undoing the presence of the cubic root and thus freeing up d in this instance, I can take the cube of both sides and so the cubic root of d to the 3rd, okay, so this will become d, and 3/2 cubed, this will be 3 times 3 times 3 all over 2 times 2 times 2. So in this case, d is going to be at 27/8. And as for what we have with the other factor, and setting equal to 0, so you have 3d to the 1/3 is equal to negative 1. And if I divide by 3, so I have d to the 1/3 is going to be equal to negative 1/3. And and writing, or re-expressing as a radical. So you have the cubic root of d is equal to negative 1/3. Okay, and now one might be tempted to say there's going to be no solution. And had this been like an even root, like square root, fourth root, it is true that even roots cannot reduce to negative constants or negative fractions, but you can have such a thing in the case of odd roots. So odd root, odd expression can reduce to a negative, and so we can follow through and once again eliminate the radical by taking the cube of both sides in the equation. So we have in this cubic root of d raised to the third goes to d, and the cube of negative 1/3, you have negative 1/3 times itself. So we end up at minus 1/27. Okay, so for this equation, okay, we're going to have two solutions for d. Okay, so again we have one, we have it 27/8, and for the other, okay, we have it minus 1/27. Again, just the Alex homework section R8. Okay, that will be due tomorrow night at 11:59 p.m. and we'll be looking into just some further review items. And on page 115, okay, now these are absolute value equations or inequalities. Go ahead and be looking into those. In this case, numbers 130 and 132. And again, just our test announcement. The first Math 171 test will be available through Alex and will be listed as Test 1 on Friday, February the 5th at 12 p.m. Again, there will be a 90-minute time limit and must be completed in one sitting. And I restate, you cannot save your work and resume at a later time, as you would like with the Alex homework. And the deadline for submitting this exam will be Monday, February the 8th at 11:59 p.m.